Hello and welcome back to the Math Mindset. So today we'll be looking at problem number 11 from the 2022 AIME I, and we'll be solving this without any trig. So let's look at it. Let ABCD be a parallelogram with angle BAD less than 90 degrees. A circle tangent to sides DA, AB, and BC intersects diagonal AC at points P and Q, with AP being less than AQ, as shown. Suppose that AP is equal to 3, PQ is equal to 9, and QC is equal to 16. Then the area of ABCD can be expressed in the form m root n, where m and n are positive integers, and n is not divisible by the square of any prime, and we have to find m plus n. So I've drawn the diagram below as best as I can with all the lengths they gave us. And a critical concept we need to solve this problem is power of a point, because we're given a circle and the lengths of chords and secants that pass through the circle. So by using power of a point, we can be able to find some portions of the lengths of the parallelogram. So with that clue in mind, let's try and do that. So let's look at the point where the circle intersects a side AB. We'll call that point A1, A sub 1. And we'll call this point A sub 2. By power of a point, we know that segment A sub 1 is equal to A sub 2. We know that by power of a point. So what is A sub 1? A sub 1 equal to? What's that segment equal to? What are those two segments equal to? By power of a point, we can use secant AQ. So by power of a point, we know that AP times AP plus PQ, the entire segment AQ, is equal to AA1 squared. Now we can substitute values in. So 3 times 3 plus 9 is equal to A sub 1 squared. So 36 is equal to A sub 1 squared. So A sub 1 is equal to 6. So we can go back up here, and we know that both the segments A sub 2 and A sub 1 have length 6. So let's mark that. And now we can use the same process to find the length of CX as shown. We can find the length of this blue segment over here using power of a point. So CX squared will be equal to, let's see, what is it equal to? It's equal to CQ times CQ plus PQ, right? That is our definition for power of a point dealing with secants and tangents, right? So it's equal to 16 times 16 plus 9. So CX squared is basically equal to 400. So we know CX equals 20. Right, CX is 20. We found that out. So let me write that here. CX is equal to 20. So let's mark the information we just found in our diagram. So we know This is 20. And this is 6. 8 sub 2 is 6, so 8 sub 1 is also 6. Right? And by power of a point again, tangents originating from the same point are equal. So this is equal to this. Right? But we're asked to find the area of a parallelogram. And how do we find the area of a parallelogram? Well, the area of a parallelogram is just, hold on, let me copy this diagram so we can look at it below. Right. Let's move this. We'll move this. Okay. So now, how do we find the area of a parallelogram? Well, it's just base times height, like any other, like a rectangle or a square. What is the base? The base is this. This is our base. Right. And the height is the perpendicular from the side opposite the base to the base. So it would be this segment here. This is the base. If we extended the base like this, when it meets the height, it'll form a 90-degree angle, or those two segments will be perpendicular. So that's the height. Right? So we need to find the height and the base. So let's do that. Actually, let me draw the height a bit better. So this will be our height. This is our height. If we extend the base like this, it'll make a 90-degree angle. So what's the length of our base? Well, the length of our base is 20 plus this segment. We'll call this y. Right. The length of our base is 20 plus y. Opposite sides of a parallelogram are equal. So that means this segment should be 14 plus y. Now, are there any useful lengths that we could draw that might help us determine the height of this parallelogram? Well, first off, we know this is also y. Let's just start labeling lengths as much as we can to see where we can go. So side AB is 6 plus y, so side CD also has to be 6 plus y, right? So let's try drawing the height of this parallelogram in different places inside the parallelogram, so that we can get an idea for what lengths we can compare to find the height eventually. So we can draw the height here, right? We can draw the height here. Actually, let me do that in green. We can draw the height here, like this. Came out wrong. Let me draw that again. So we can draw the height like this, approximately. And well, we could also do it here. We could connect two ends, the two opposite tangents of the circle, like that. Tangent points, we can connect the tangent points like this. And we know these will form 90-degree angles because the tangents of a circle form a 90-degree angle with a line that passes through the diameter of the circle, right, to a tangent. tangent point to diameter circle, always a right angle. So we know that works. And we know all the green segments we just drew are equal to the height of the circle. So I'm going to call that h. So this is h, that's h, that's h. And here we know this, we've made a rectangle over here with width y and length h. So this part is y. Let me draw that in red. This part is y. And if AA2 is y, then the part I'm going to change right now, so this part is 6 minus y. Right, because the whole thing, AA sub 2 is 6. Well, whoa, would you look at that? I see congruent triangles. I see, let me highlight. This triangle and this triangle are congruent by HL theorem. Their hypotenuse is both 6 plus y and 6 plus y, and their heights are both h. So that means their bases are the same. So this part over here is 6 minus y as well. And now we can consider the larger right triangle. We can consider this larger right triangle over here, right? It has a base length of 6 minus y plus 14 plus y plus 6 minus y. And when you add those up, that's equal to 26, right? And the hypotenuse length is 3 plus 9 plus 16, which is 28. So we have an equation for h. Right, so let's do that. Let's find it. So we can write 20, I'm in highlighter. We can write 28 squared is equal to 26 squared plus h squared by the Pythagorean theorem. So h squared is equal to 28 minus 26 times 28 plus 26 by difference of squares. It's a neat trick I like to use. That's equal to 108. So h is equal to 6 times the square root of 3. Alright, so we found h, but we're not done yet. We still have to find y. Well, luckily for us, we can use one of the right triangles. We can use one of these right triangles. Underline, traced in blue. We know the value of h. So let me redraw one of those right triangles. We know the value of h. This side has length 6 plus y. This side has length 6 minus y. And h is just equal to 6 times the square root of 3. This is a right angle. We can solve for y using the Pythagorean theorem again. So we have 6 plus y squared is equal to 6 minus y squared plus 6 root 3 squared. This becomes y squared plus 12y plus 36 is equal to y squared minus 12y plus 36 plus 108. Right. Y squared terms cancel. We can move all the y terms to one side. Right. The 36 also cancels. So we get, finally, 24y equals 108. We can take out a 12 from both sides to get 2y is equal to 9. So y is equal to 9/2. Found the value of y. Oh my god, we're almost done. So we found the value of y, so we can substitute that in. So let's pull out our eraser, substitute our value for y. That's gone. We know they're both 9/2 now. So that part is 9/2. That part is 9/2. So now we can find the area of our parallelogram. So to find the area of a parallelogram, we just have to multiply the base, which is 20 plus 9/2, which is 49/2, and the height, which is 6√3. So 49/2. Let me do it somewhere else. So our base is 20 plus 9√2. Right, that's our base length. And our height length, h, is 6√3, as we discovered a while ago. And when we multiply this out, we get the area of the parallelogram is 147√3. So our desired answer, m plus n is equal to 147 plus 3, which is 150. And that's our final answer. If you enjoyed learning how to solve this problem with me, please don't forget to leave a like and comment your thoughts down below and share this video with those who might find it useful. And as always, I'll see you next time. In the meantime, check out this video, or if you have the time, check out that playlist. But don't forget to subscribe.